and
Okay.
so I just
Just
click it,
give me
and
the thumbs
then
up and I'll go from there.
sounds good. I'll introduce you. And all right, excellent. Well, everyone, thank you so much for joining us tonight at Pyre VA. I'm excited to be here. Thank Roland. Thank you for being tonight's speaker. I'm excited to hear what you have for us tonight. I've already forgotten. I meant to have a little note to say like what you're going to be speaking on. I know it, data sciencey, but I don't know.
No problem. I can reiterate.
Okay, great. Um, quick question: Do you want, if people have questions, do you want to wait till you're at the end of your talk, or do you
Oh,
want
no,
them to
no.
ask? All right, cool.
Jump in whenever.
Sounds great. Well, then I'll hand it over to you.
Okay. Well, welcome everybody. For those that don't know me, I'm Roland DePrati. I'm a graduate student in data science. I've attended a few of these IRVAs, but you may not know me because of COVID and online. And also, my wife and I are in Connecticut for a good part of the year. So when I came every third or fourth time. So it's hard to remember someone that only comes once in a while. So my talk today um, has to do with, whoops, let me go to the top here, has to do with exploring data, right? And using three tools I use all the time: Jupyter Notebooks, Pandas, and Matplotlib. Um, I spend a good part of my day using these tools to get familiar with data, sometimes 30 or 40 or 50 or 80 lines of code to run 4 lines of code that I really want to do, right? So it's really where I spend a lot of my time. Now, let's see, how do I do this? Is there a way for me to show your faces while I'm presenting? There must be, right? Hmm. Well, that's okay. You guys can see my slides, right?
Yes.
Okay. So let me talk. I'm going to talk a little bit. The layout of this session is basically I'm going to talk a little bit on a high level of what these tools are in case you're not familiar with them. And then I recently, the last few weeks, last 4 weeks, I've been spending some time with with a large data set that deals with hospital admissions in an ICU. And I'm going to go through a notebook I've been using to get familiar with the data, and we'll see how I use these three sets of tools to kind of get familiar with the data. And like I said, jump in if you have questions. Go all feel free to jump in anytime. It is I spent a good part of my time working with programming and programmers, and it's boring reading somebody else's code. So I'm not going to go line for line. If you have a question, feel free to jump in and ask. I'm going to talk a little bit. I'll point out some things in the code so I don't bore you too much, and see how it ties back to these 3 or 4 things that we're talking about. But I hope not to bore you. And if I'm going too slow or if I jump in too deep, feel free to yell at me. Okay, so Jupyter Notebooks is a tool that was invented out in University of California. I think it was in Irvine. And the idea was basically this: is that wouldn't it be nice to have a tool that was relatively easy to use, that would allow you to mix code that you could execute as well as explanation and graphs and images that would explain why you're doing what you're doing, right? I mean, for years in IT, I spent a lot of time either writing my own code or going through other people's code and then trying to track down where did the documentation go? If there is any documentation. The nice thing about Jupyter Notebooks, it tries to put everything together. So you can go from an initial thought about what the person's looking at in English or the graph or whatever, and then jump down and there's the code he used to do that. So it's a really shareable environment. It's easy to see. They get saved in a standard format. The tool itself is a little tiny web browser that runs on your desktop or can run in a server, and it feeds up your notebooks and allows you to edit them and run them and do whatever you need to do. So they can run either locally on your laptop, which is what I'm doing here, or they can run on servers where you can tie in through a web page and actually they can run on a beefed up server if that's what you need. when the product first came out, they did a very nice job of talking to different development communities to find out what type of programming languages and what kind of tools would be handy in this kind of environment. And a lot of people stepped up. A lot of proprietary languages like MATLAB, not MATLAB, some of the math packages, and also the people that do open source programming languages. And what they did is they wrote code so you can run code from a notebook for dozens of languages and tools. So it allows you to mix, not just like I'm going to present you Python, but you can run R in those same notebooks. You can run all kinds of C, C++. There are hundreds of kernels that allow you to do that. Okay, Pandas, for those that don't know, it's a Python data analysis library. Its main data structure is something called a data frame, which is very similar to a relational table. It's basically, or a spreadsheet. It's a list of headings and data types for those headings and the data that falls under those headings. So you can read data into a data frame, and then you can do all kinds of things with it. There are many methods within the library that allows you to change the data, that allows you to redefine other data frames, allows you to combine data frames and data, summarize and extract them. And it's a very handy tool. If you're familiar with SQL and you've done things like joins and group bys, all those operations are available in Pandas, and you'll see a lot of examples of that as we go through some of the code. Okay, so Matplotlib is a very familiar Python graphing library. There's lots of types of graphs. It works easily with data frames. It can be confusing. There's lots of fancy things you can do with it, but sometimes it takes a while to figure out how to do that. It's not you can do some simple things really straightforwardly, and I'll go through lots of examples for you as well. Any questions yet? How we doing?
Doing good.
Okay.
Doing great.
I should mention Jupyter and IPython came from Berkeley, UC Berkeley.
Oh, was it Berkeley? Okay.
Yeah.
Thanks.
Yeah.
I knew it was out in California. Okay, so this is my goal. I'm going to walk through an example of analyzing a series of files that was part of some EDA work I was doing using all the aforementioned libraries. And here's my problem. So I have 10 years worth of ICU data that MIT curated in something called their MIMIC database. It's got 54,000 admissions over a 10-year period. So anybody that walked into the emergency room or ICU of this hospital for 10 years, their data was captured, it was de-identified, so they have their privacy, and it was curated on this database that's basically a series of files. People use these files in a lot of different ways. Some of them some researchers like to load them up to relational tables and then run queries against them. I tended not to do that. I keep them in their normal Parquet format because I'm familiar with working with Parquet, and it allows me to use a lot of the tools that I just talked about. There's lots of files that are part of this database. Some of the files I'm going to be looking at are admissions, the admissions diagnoses, and the patient's notes. Okay, did I describe the problem here? I did not describe the problem. Okay, so let me tell you what I did describe it here. Okay, so my goal is this. I want to look at this data and I want to determine if I can predict the diagnoses by examining the first few days of patient's notes, right? We're going to see when I show you some of the charts that there have been patients that have gone into this ICU and have spent 900 hours in the ICU, right? Or longer, right? That's a lot of days, right? And a lot of the work in an ICU, besides stabilizing the patient to send them on to their next, either discharge them or send them upstairs to a different floor, was to come up with a reasonable diagnosis. And there's all kinds of data on this database that are measurement based, right? They do MRIs, they've got that captured, they've got all kinds of tests that they give, they've got what kind of food the patient ate. They've got all kinds of things, right? But my take is basically this, is that the people working closest to the patient are the nurses, and as well as doctors when they attend to the floors, right? My thought is that in the description, every night, I'm not sure if any of you guys have worked in a hospital, but many decades ago, patients' notes were invented as a means to pass information from shift to shift in the hospital, right? I worked in an inpatient psychiatric unit for kids for 3 years. And every day at 3 o'clock, one of my jobs was to sit down with the patients I was working with and give the updated day to day about what happened to that patient. Is there information that the next set of folks coming on need to know to deal better and to decide what to do next with this patient, or how to make them get healthier. But that was the original goal. But those are also the people that are closest to the patient. And my thesis or my idea is there's lots of detail that you can't capture in a measurement or in a test or in an MRI that probably would be very germane to what the person's diagnosis is. And my goal after the EDA is actually to run NLP processing against this data and see if I can map the patient's notes to their actual diagnoses. And if I can do that quicker than when the doctor did it, it might be information the doctor can use to make the diagnosis quicker. So that's my goal. Today, we're just going to explore the EDA side of it to give you a little bit of feel of what the data looks like and how I went about doing that. Okay, so let me go over to my notebook. So this is my notebook. I do the standard stuff. I import the libraries I need. I identify the file paths I need, and then I start building data frames, right? So the first three the first three files I read in are a file of diagnoses codes, which are just a code table of the valid codes and their descriptions. The admission diagnoses, which is the diagnoses associated with the admission. And finally, admission information. Like when were they admitted? How long were they there? Information like that. And then I start working with it. Now, I am actually focusing in. I don't want to look at all 54,000 people. I'm actually focusing in, and did I label it up here? I'm actually looking at people that have intestinal conditions, right? So things like IBS, things like issues, stomach issues. You'll see some of the diagnoses. Actually, we're going to bump into them in a second. So I'm focusing on a core group out of these 54,000 admissions. And one of the things I want to do, let me see if I have this here. Yeah. So one of the things I want to do is I need to do a conversion, right? So for decades, there was a code that was used for diagnoses called actually it's still a code. It's called the ICD code, the International Code of Diagnoses. And they had a code that was developed over the decades. The process basically was this. We have a new diagnosis. Do we have a free number? Yeah, let's use this number, right? There wasn't a whole lot of structure to the numbers. So about 2015, after many years of complaining about it, a committee got together and developed a hierarchy of diagnoses so that the numbers are related, the codes are related. You come in from the top, you have a very high level diagnosis, and it kind of branches down to lower level diagnoses. And it's really helpful because it's very descriptive about the nature of how some of these diagnoses come together and how they're related. The mimic data that I have, unfortunately, has the ICD-9 code. And so I need to convert it. So I have a table that basically is just that. It's an ICD-9 to ICD-10 diagnosis mapping table. I read that in, and you see here's a couple of rows of that data. You see the ICD-9 code, the ICD-10 code, and you see a little description about it. Okay. I do some renaming, blah, blah, blah. Okay, and here's the full list. Okay, so now I want to drill down to these patients. So what I've done is I've come up with a list of terms that tie to these diagnoses that I want. And I'm going to be looking in the diagnoses, the ICD-9 diagnoses table to identify the diagnoses I really care about. So I'm going from description to actual code. And that's what this does, right? So I go against the long title of the description of the code. I see if it contains one of these terms. And if it does, I basically take that data and I merge it with the admission diags. Now, I'm not going to go through every case, but because this is the first time we've seen the merge method called, this is, for those familiar with SQL, this is your join, right? So it's saying you've picked up some of these wanted diagnoses from a code table. Go back to the admissions and find all the admissions that were diagnosed with one of these codes, right? And so it has the first data frame, it has the second data frame, it tells you how it's tying together, right? Join the two files on the ICD-9 code and bring back this list of columns. I get rid of duplicates. And then I want to start looking at this data, right? So the first thing I want to do is I want to see how do these people group, right? The first thing I want to pay attention to is that a patient might have more than one diagnosis, right? And I don't want to get into trouble of double counting an admission, right? So I might, the admission diagnosis table might have two records on it for the same admission, just with a different diagnosis code. So I use group by to basically build a new field that is a list of diagnoses. And so now I have this intestinal folks data frame that basically has one row per admission, and each admission has a list of diagnoses that are tied to it. And the next thing I want to find is I want to find out, are there any patients that do have more? How many patients have more than two, right? Because that might be an issue for my later work. You know, I need to know, were they both related to this? Or was it? Pardon?
I'll just chime in. You're doing quite a bit of stuff in that cell up there, that 20-line cell, right?
Yeah.
It might be interesting, you know, in another version of this lecture, to split out the intermediate, you know, data frames as well as fields, so that it's clear to us exactly what's happening.
That makes sense. Yeah.
That's just a
makes sense.
Like temp folks, we could do a temp folks.head, because I'm kind of curious what you know, what the wanted diags are, and you know, what happens from admission diags.head to temp folks.head. That might be useful to see, because yes,
Okay.
I think a lot of us are seeing it for the first time.
Okay. Well, let me slow down then. Let me go through those steps, because I don't want to lose you. So what the wanted diags are is I'm going after that diag code table that has nothing but codes on it and descriptions, right? And I want to
see what the field is. Yeah,
if we can see what
that is. Yeah, what it looks like.
Oh, we can do that.
Yeah, that would be great.
Let's see. Let me. I'll print the first 5 rows of that.
Okay.
Oh, maybe I need to run these. I thought I just recently ran them. It looks like I didn't. Let me run through that.
One of the small problems with Jupyter notebooks.
Right. Right.
I'm the same way at work. You know, somebody gives a demonstration, and I'm like, let's stop right here. And
oh, sure, no. There's no use for me to talk for 20 minutes if you have no idea what I'm saying, right? So I appreciate the feedback.
Okay, thanks. You can also try the ICD9_df.head. That would be interesting to show. I don't know if you're
Okay,
aware of that
yeah.
data frame method.
Yes, I am. I am.
Okay.
Okay, so let me
Right.
go back here and run this, and I think we should see what it looks like.
Yeah.
There you go.
Yeah.
So the original table looks just like this. The only difference is there's more rows on it. Right?
Okay.
Because if you look down here, what I'm doing is I'm taking this long title and
You mean it
I'm
has more columns or more rows?
more rows.
Okay.
Because what I'm doing here is I'm taking the original diag codes table and I'm saying only give me the rows that have one of these terms
Hmm.
in its description. Because that's going to give me the diagnoses that I care about for this study. Does that make sense?
Yeah.
Okay. Now, once I have this again, I have no admissions yet. I have no people. All I have is this list of codes that I care about. So now I want to tie them to an admission, right? And there is a file called right down here called admission diags that has every admission and the diagnosis related to it.
Can we take a look at that? I'm just curious,
Sure.
you know.
Sure. We can just change this right up here.
It's got different columns too.
Let's see, is that spelled right? I think so. Admission diags. Yeah. Ooh. Where'd it go? Here it is. Oh. Where did it go?
There was a Jupyter notebook, which is in a browser. There it is. Okay.
Yeah. Okay, so this admission diag, now notice it has, ooh, that's not right.
I think you actually clicked on it went a cell above.
The wrong
so
one. Yeah, I
yeah.
ran the wrong one. There you go. So this has now the patient, the subject ID. It has the admission ID, plus it has the ICD-9 code attached to it.
Okay.
Okay. Now the examples on the screen only have one ICD-9 code, one diagnosis per admission. No, actually, we have two. So you see, let me think. What do we have here? Yeah, if you look at
Let's see.
admission 172335,
Mm-hmm.
it's got two rows. The first, actually, it's got four rows. So for this patient on this admission, he was diagnosed with four codes.
Okay.
You follow me?
Yeah, I see that. The identifying key is Haddam ID _ID. Is that correct?
That's the admission, correct?
Okay.
Okay. Now, what I'm doing in temp, folks, is I'm putting those two things together. I'm saying, show me the wanted diagnoses that I cared about, that I selected above, and join those to the ICD-9 codes on the admission diagnoses. That way I get the admissions for the patients for the diagnoses I care about. So this is like a SQL join, right? I'm joining one table to another, and I'm joining it on diagnoses code. So now I get not all the diagnoses, not all the admissions, but just the admissions for the diagnoses I care about.
There's some kind of filtering, right? So I'm interested to see not only temp folks, but also the size of admission diags and temp folks. You know, because I think that's what's happening here, right?
Yes. Yeah. So you're going to see admission. You're going to see this being quite big. Oh, maybe I should spell it right. Right. So there are 651,000 rows on admission diags.
Uh-huh.
And if I look at temp diags, or is it temp folks? Temp folks.
Temp folks, yeah.
You're going to see quite a few quite a bunch fewer.
Yep.
Got 11,000,
Okay.
right?
That's really cool. All right.
So now what I have is I have this list of admissions that have the diagnoses I care about. The rest of this stuff, what it's doing is it's looking for problems. It's looking for things I should care about. Like, for instance, found diags is just dropping duplicates, right? So if for some reason I have some duplicates in those rows, I get rid of it. Now there shouldn't be, but I do that just out of good practice. The next thing I do, so we noted earlier that an admission might have multiple diagnoses, right? If I'm ever counting or analyzing admissions and I'm counting it based on rows, because an admission might be on multiple rows, one for each diagnosis, I might get a misleading answer. So what I want to do is I want to have one row represent one admission, one patient's admission. And I want to make those multiple diagnoses, I want to make them a list on that admission. Actually, let me show you rather than count them. Let me show you them. That way you'll see what I mean.
Yeah, let's say I'm very curious as to what that looks like.
So do you see how
Can
the
you show
Mango
one?
now is a list?
I see it's a list, but what would be useful is to show those rows where the list has more than one element.
You're not going to believe me that's what it does? Yeah, let me do that. I can do that for you. Here you go. Here is this list right here. Identifies all those where the length of the list is greater than 1. Actually, I show them down below here. I print them down below here. Here's your list. See them?
Okay.
So as part of the rest of that section, what I'm doing is I'm finding out how many diagnoses in that original code table did I find that match what I want. I said there's 35 diagnoses. I said how many admissions actually had those diagnoses? It came up to 10,000. And finally, how many diagnoses had more than one? I had 854 that of those 10,000 had more than one. And the actual even though the code table said 135 of them you care about, only 85 of them were associated with a patient with an admission. So the other 40, I think it's 40, right? The other 50 actually. The other 50 out of the 135 did not, in 10 years, a person was never diagnosed with one of those diagnoses, with one of those conditions. So my list got skinnier. Instead of 135, now I've got 85 diagnoses I care about and admissions that actually match them. And some of those that I've matched that I found, here's a list of the found diagnoses down below here. Now, one of the things for large, it'll tell you that I've got 85 rows, but it'll abbreviate that. And you'll see the 3 dots in the middle there. You can get around that just by changing the set option to display more things if you want. That's what that command does. Okay, so what have I done? So now I've got the admissions I care about. I found some initial information about them. How many have duplicates? How many actually of the diagnoses will I be dealing with? Now what I want to do is now I want to do that conversion I talked about. Now I want to go from ICD-9 to ICD-10. And of all those diagnoses, I want to identify what the primary diagnosis is. And that's simpler than it sounds. All I need to do is find the first diagnosis in the list, identify it as primary, and then convert it to ICD-10 with the table that I had above, right? So what I did is from that data frame that I read in, I built a dictionary that maps the ICD-10 to the ICD-9 to the ICD-10. And then I bring in those intestinal folks and I say, create 2 new columns, primary ICD-9 code and primary ICD-10 code. And for every row on that table, I want you to pass the ICD-9 from that row to this function, and that function does the conversion. Just in case, let me, Oh, I guess I didn't identify that. Oh, I didn't run the dictionary. That's right. I gotta stop skipping steps. Okay. Okay, so here is my new data frame, right? And I'm calling it, this is my intestinal folks updated data frame. So now I have my subject, I have my admission, I've got my original list.
Sorry, I'm gonna interrupt again. Cell 26 evaluated. It's like line 12 and 13. Are they separate bits of code? Because it's hard for me to see. It seems to run off the columns. Can you split that out with a line break so it's clear to me what exactly is happening? Okay. I meant is it possible to have maybe a return statement after func1 left paren so that it's clear that, okay, what exactly are you evaluating?
Okay. So let me talk here. So there is this right here is a function that's defined.
Yeah. That's not the issue. It's just,
and it ends on that return.
I know.
So you're looking for what?
Where it says intestinal folks, if you could put a return statement after that. So a line break so that we can all see what that is.
Oh, I see what you're saying. What you want to see is you want to see what's at the end here.
That's really hard for me to follow because I can't. Yeah. So if you put a line break after func1, space, that would be really cool. Yeah, that's much better.
Okay, makes sense?
Yeah.
Yeah, now it does.
Okay. So the end result of this is that I end up with an augmented data frame that, besides what I had before, it now has a primary ICD-9 code and an ICD-10 code. It did the conversion, it identified both, and it has 2 new columns. Okay. I think I read that right.
Is there an implicit none filtering in here? Because if diag and dedict, it returns it, and if it doesn't find anything, it returns a none. And then there's some kind of func1, I guess, intestinal folks. If there's doesn't find anything, right? What happens? It just doesn't. That row is removed.
It plugs in a none in it. It plugs in an AN, a null, right? Because nothing's coming back.
Is there a intestinal folks, I guess, column or row that has primary ICD-9 or ICD-10 codes that has an NAN? That might be interesting to take a look at too.
No, they don't. It plugged all of them in. It is I double checked to see if we're going to end up with any ICD-9 codes that weren't on this master list, and I didn't find any.
Oh, okay. So you don't really need the return statements?
True. Yeah.
Okay.
Yeah.
All right. That's clear to me now.
That's just there for my readability. because I can see that that's the end of everything, right?
Okay.
Okay, and here are the columns that are on that new table, and you see the ICD-9 code and 10 code added. Okay, so now what I want to do now is I want to come up with a broader list of data, right? On the admission table itself that I haven't dealt with at all. We've dealt with the admission diag, which is nothing but some basic admission key and the diagnoses related to that admission. I want to go to the admission table and bring back a whole slew of data, because this is probably the data I'm going to filter down on to kind of look at how different data breaks up, right? So that's on the admission table. And again, I'm doing another merge where the intestinal folks I just updated. I'm also joining on admissions, again on the admission ID and the patient ID. And I'm bringing back all this extra data, their religion, their ethnicity, their diagnoses.
One question.
Yeah.
The admit time and discharge time, why do they say 2170 or 2131? Is this an anonymization thing?
Yes. Yes.
Okay.
The dates are relative, but they're not accurate.
Ah, okay.
And there's a formula to play with them so you can use them, but you never find out when it actually happened. You know all this data was created between, I think it was 1999 and 2011.
Okay.
But you don't know what the actual date was.
Okay.
Is that I mean, maybe it's not too topically important, but is that like a HIPAA thing? I just find it interesting.
HIPAA thing?
Well, it's not so much HIPAA as this is research data. And when you're doing research and humans are involved, you have to make sure that there's very little way for you to backtrack and find out the patient. And that's one of the de-identifiers they do, is they play around with the date. I also had to go through a 5-section online course and sign a bunch of forms to let them know that I wasn't going to pass these files on to anybody. And secondly, I wasn't going to try to find out personal information about anybody. So I guess you could say this HIPAA related is privacy.
I see. Okay. Thank you for explaining that.
Oh, no problem. So this last piece here, what I'm doing is I'm taking the date fields and I'm actually formatting so that they're date types and not just strings. That's all this does. I probably should run this stuff, not just scan by it, or I'm going to have problems later on.
What is
Go ahead.
the error you're allowing for errors in block 13? Errors coerce?
Yes. What coerce says is generate a date as much as you can if there's any problems. It guarantees some kind of a translation.
Oh, okay.
Now, what you see that's interesting here is that you see that we have a combination of both elective and emergency patients, right? And we can see from this small list, we have some people that are on Medicare. You better believe there's other insurance companies that are listed here down the road. And you start looking at some of the stay hours, right? So just to these first 4 rows that are on top in the middle of the screen here, you see patients that spent up to 460 hours in the hospital. And that's not in the hospital, that's in the ICU. Right? So what's 460 hours? That's at least 10 days, right? It's more than 10 days, it's close to 20 days.
Mm-hmm.
Right?
Well, you actually have it right there. The discharge and admit time was that month, right?
Oh, there you go. Yep. Yeah, was it 19 days? Is that what it looks like? Yeah. Good point.
19 days. Yeah.
Now, what I want to do, Don, is I want to kind of move ahead here a little bit, because we're starting to get into some interesting stuff. What I found is, so I started looking around, and hospitals are like anybody else, right? What happens is they have the greatest plans in the world to keep organized, clean data. And in some cases, they end up copying data someplace else. And those are the kind of problems, one of the types of problems that really interest me, especially when there's discrepancies, right? So it turned out that not only was there a diagnoses code assigned to these admissions, but on the admission itself, the doctor wrote in or typed in verbiage about what he thought the diagnosis was. Right? Now, all of these things have to do with intestinal. Well, look at some of these descriptions. Chest pain, shortness of breath. That doesn't sound like intestinal. Congestive heart failure. Now, was that because the initial diagnosis was way off what the doctor eventually settled on? And is that the space where I can provide information to the doctor to help them out, right? That's kind of where I'm going with this. Okay, so that is just okay. Now what I'm doing, so now I'm getting down to some summary information, right? So I have this data that I put together, this intestinal admissions data that has all this stuff put together. What I want to do is I want to start summarizing to see what I can see, right? So what this merge and group by does is that it joins some data and it aggregates, it summarizes the stay hours, the length of stay in the hospital. And it generates a min, a max, an average, and a count by diagnoses code. Right, so right off on the top, here's my list of diagnoses I cared about, or a subset of them. And you'll notice that the top one, which is the new code is K92.2, that I have 1,300 patients that were diagnosed this way, and somebody spent 4,000 hours in the hospital with this diagnosis. The average was 289 hours, which is still a pretty good amount of time. And for some reason, its minimum is less than 16 hours. So I'm not sure what that was. It sounds like it was a typing error, where someone put in a minus versus a plus. And then here's a list going all the way down. These are sorted.
Well, actually, you can check if when they were admitted and discharged, right? That would be the validation. I think maybe you can ignore one of the fields, the stay hours, because you actually can use the admission, the discharge and admission,
That's true. I could double check to make sure the stay hours match the subtraction of those two date times.
Or just ignore one, it's up to you.
Yeah. Yeah. Which one do you trust, though? Well, certainly not the minus 16.
Well, it's not like you can call these people and fix their mistakes, right?
Exactly. And I sorted these, and this is some, if people haven't used, here's a very, very powerful way to use Pandas, right? So it gives you the power to merge, to join files. And so I'm joining my intestinal admission table that we put together earlier, and I'm matching it with the diagnoses code, that original table that had all the diagnoses in it, because I want to get the long title. And I'm grouping it by the ICD-9 code, ICD-10 code, and long title, not because long title makes it different, but I wanted to get the counts and have all three things on the screen. So I get all three things together. I get the description and the two codes. And then I generate some aggregation. I basically produce a min, a max, and an average. And I give it a name, and I tell, this is the column I'm using. I'm using stay hours, and I want the min, max, and mean, which are methods that Pandas knows what it means, and it calculates them. And then it also generates a count.
Roland, I have a question real quick.
Sure.
On when you're merging, so you specify the column, the left on column that you're merging, and then the right on column that you're merging. Is that like doing a left join and then a right join in SQL? What is that?
Yeah, it is that, but this actually that's actually a typo I didn't catch before. they should both be left, right? Because my concern here is I want to get the admission whether or not there's a diagnoses code. And this was my test. Who mentioned this earlier? This was my test to see if I ended up with any columns that didn't have a description, a long title, right? If I had an admission with a primary 9 and 10 ICD-9 code and had a bunch of numbers, but I had no long title, that told me that here was a code that wasn't on the code table. Right? I know somebody brought that up earlier. But yeah, they're supposed to be both left on because I really want to get the admission whether or not there's a code on the diagnoses code table.
Okay, thank you.
Yep. And I just round it because I don't want all the decimals from the averages, and I sort it in descending order so I get the highest amount of count on top. Okay, and then the next thing I do is I just basically do a shape on my intestinal admission, and it tells me that I still have 10,000 records that I counted earlier. Okay, now here is actually something that I did piece by piece, and you'll see later on I figured out a much more efficient way to do it. But my goal is, so I have on that chart, and let me go back up here. On that chart, you'll see that if you cut things off about here, you catch a good amount of the admissions, right? These are all the big numbers. So if you pay attention to the Ks, you've got a pretty good list of admissions, number one. And number two, remember how I told you the ICD-9 work that they did was meant to group things in a way? This is a grouping that is a mid-level grouping. For instance, you'll notice there is where are they here? Let me raise up here a little bit so I can see the full list. Because these are sorted by counts, it's hard to see the relationship. But if you look at the second row down, K2990, go down about 6 or 7 down, and you'll see there's a K2991. Right? Those are two codes. One is unspecified gastritis, and the other one is unspecified gastritis and gastroduodenitis, right? So those are two things that are very related, right? And there's let me see, what else is there here? There's a 56, I think. There's a 5660 and a 5669, which are different types of intestinal obstructions. So you're already starting to see there's a grouping here. So what I wanted to do, my next step was, well, let me focus on those. Let me focus on the 10 high volume diagnoses and see if I can see some patterns in them, right? So my first step was, well, what I'm going to do is I'm going to build an overlapping bar chart. That was my initial thought. And I built it piecemeal. What I did is I built 10 files. And if you look to the right, each one of these files selects the intestinal admissions for a particular diagnosis code of the list we just talked about. And what I'm bringing back from this is just the stay hours. Right? So in each file, I've got the stay hours for a particular diagnosis. And then I go through the process of building a histogram for each with a different color mapping. I then also do some counts on how long each is. And I display that on a chart to go along with the histogram. And this is what it produces. What I find, it's always easier. What I find is it's always easier to fix my code, right? Once I got something working, I can say, boy, that was the wrong way to do it. And then I can go back and I can simplify it. And that's exactly what I did down here. What I did down here is I said, you know what? I do the same thing for every diagnosis. I build a file. I build that file based on a diagnosis code. I display a heading on a chart based on a diagnosis code. And so what I did is oh no, maybe I didn't do that here. What is this? Let me think. No, I did some of it, right? So I build my files using this ICD-9 codes 2 table, and it all runs from this loop, right? After I set up some charting parameters that I want all the charts to look like, I run this loop, and what it does is for each item in this code table up here, each item in this dictionary, I build a file, I set up a histogram, I label the histogram for the code that comes from the code table, from the dictionary. I then build a text that basically bills the number of rows in that file for that type, and then I put it on the screen, and I end up with the same thing. Right now, here's the catch. For some reason, I gotta still sort this out. For some reason, all this extra code in the middle here, I had it as 2 line entries underneath this for loop.
You know what would be interesting, and this is giving you more work, is have a density plot, 2D density plot, length of stay on one axis, and maybe code on the y-axis. I don't know.
Make sense? Yeah.
And
Yeah.
color, and the dot would be, or that cell would be frequency.
Yeah. Yeah. Right. That would be another way to present this. I'm trying to do a similar thing. I'm on this chart. I'm showing for each of those diagnoses. Do you see listed on the right table? I'm listing how frequently they had a particular length of stay. Right. So if you look at the 100, that's 100 hours in the hospital on the x-axis, and that the yellow, which is the very top one, which is K2990, had 35 people that stayed 100 days.
Right.
Or in that
I'm
range,
saying
right?
that you can have a y-axis being these separate codes, and so then I know for me it would be clear that, oh yeah, it's definitely this one, dominates the shorter versus longer stays, or well, yeah,
yeah.
it's a whole art of visualizing.
Oh, it is, yeah. There's 100 ways to kill the cat, and I appreciate the feedback. You're right. So now I said, you know what?
Right?
I kind of like you, is I don't like this diagram, because when you put too many things on top of each other, it's hard sometimes to tease things out, right? Like I could tell some things. I can tell that that K5660 goes right to the end. Those are the longest ones, right? As well as K589, right? And as well as the khaki one, K69, K5669. But I'm not quite sure where the orange ends, right? Does it end right here? Or what happens is what Pandas does, or Matplotlib does, is it bleeds the color if 2 are there, right?
Well,
so you'll see this.
There's different color maps you can do. Yeah, it's a whole thing. Or there's a whole art behind that too.
Right.
Like,
right.
Sort of adverse or just very big adjacent delta color maps.
Right.
To plus even stuff for colorblind people or various species of colorblindness. If you look at the colors section for Matplotlib, it's a good way of getting further confused.
Yeah, there's tons of them. I hear you. So what I did is I said, you know what? Let's do this. Let's split out the maps, right? Let's split out the charts that shows me by diagnoses code what does the distribution look like, right? And one thing nice about Matplotlib is it'll if you give it. And for those folks that haven't seen it, let me go back and I'll show it to you. Oh, actually, let me go down here because I think it's easier to read down here. Because I clean this one up to make it more efficient. So if you look here, what I'm telling it is I'm saying, I want you to build rows and columns. I want you to build a figure that has 5 rows in it and 2 columns. And I want it to be 8 by 10. I think figure size actually is in inches. I want it to be 8 by 10, and I want you to put 5 and 5 in there. 2 rows of 5 graphs. and each graph has its own axes. And then I put out some generalized stuff, right? How far apart they need to be. And then I go through this loop that says, okay, do that, build a graph. And if you notice that around the axes here, I have rows and columns that I'm incrementing down here. So it's walking away, it's walking along, dumping a graph in each axis, in each row / column, right?
Mhm.
And I end up with this diagram. Now, what's interesting, when you do that and you give it the high-level specifications and you give it the data, Matplotlib is very good at figuring out what that graph needs to look like. So if you notice the very top, they're very related, right? They have that schema. They have that the same first 3 digits. One is 0.0, one is 0.4. They're both also related. I have the counts here, how many total admissions I had. But look what it did with the frequency. It was smart enough to say, you know what? The highest number I've got in 25.0 is about 6 or 7. Yet 25.4 has a lot more, and I'm going to have a graph up to 30. I didn't do that. I didn't have to figure that out. Matplotlib did all that math and figured out how to do that. So it ends up with a very nice output, but you need to be careful. You can't make the assumption that each graph, because it's the same size, is talking about the same, what's the right word for it? The same ratio, right? So you got to pay attention. Oh, we're only
The
talking about
domains
6 here.
are not the same necessarily.
Right.
Yes.
Right. So like when I'm jumping ahead here. When I first showed this to myself, I looked at it and I said, well, isn't this funny? I have this choppiness right here. Why would it be so consistent? And I looked across and I realized, well, because there's only one. I mean, the most for a given length of stay, the most people were 3, and we're talking about either 0, 1, 2, or 3. So things are going to look very boxy, versus something that has 30 are going to be varied more, and it's going to have a very different looking distribution. Okay, the next thing I did is that I wanted to find out. I'm not sure if you guys worked with box plots a lot or at all before, but box plots are a very good way to give you a sense of how that distribution looks. We know already by looking at this that all of them tend to do the same thing, right? There's a lot at the beginning. A lot of people have length of stays in the 100, perhaps 200 range. But as you go out farther right, the number gets skinnier and skinnier. And that's what you would expect, right? Unless it's a diagnosis where the person is going to pass away, you're hoping people are getting better and getting out of the ICU, and fewer people have long stays. And the box plots kind of say that. If you haven't dealt with box plots, the middle line or the indentation in these structures is the median. And that's a very good statistical number. What I mean by that is the mean or the average can be very misleading, right? You can have 5 people in a class, and I had a class like this when I was in graduate school for computer science. I had a computability and complexity class. And it was one of those, it was a class of 30 people. It was one of those classes where the average 90% of the kids got less than a 40, right? But 2 or 3 kids got a 70 or an 80, right? So what happens is if you take 5 kids in a class and you get one kid gets a 10, one kid gets a 20, one kid gets a 30, one kid gets a 40, and another kid gets an 80 or 90, you look at the average, and the average is going to be about 75. And looking at that number, oh, that's pretty good. 75, that's a little bit above a C. That's a good class. Well, it doesn't show the true information. The median is the exact middle person. Like in that example I just gave you, the median would be 30, right? Which is much more representative of the class I told you about, right? And then what the median does is what a box plot does is it figures out, given all the data you've given me on this particular item, how do the things break down in quartiles? So from this line to this line to the first blue line, that's the first quartile. From here to here is from the second quartile, which goes from the second, well, beginning of the second quartile to the median, which I talked about. And then this is the end of the third quartile, and then this is the fourth quartile. It calculates, based on how the data is distributed, what are the 4 quartiles for this data set. And what it tells, for all of these, what it tells you is there's a long right tail, right? Like we saw in the diagrams. There's lots of things here in that fourth quartile that stretches out, which is a lot longer than what's in the first quartile, right?
Mm-hmm.
And then if there's a calculation that goes through, says, well, with all this calculation for this distribution I've got these things that don't fit in anywhere. And that's what these dots are to the right of the bar. These are things that could potentially be outliers. So here we've got something that's unspecified gastroenteritis. And look at this guy out here.
Mm.
The fourth quartile was around 1,000. And this poor guy was in the hospital for 5,000 hours, right? Now, that could be signals of 2 things. It could be a difficult case that had lots of problems, or it could be a true outlier, which means it was data that was captured wrong. And it goes back to what was mentioned before. Look in the data to see which case it is. Go back to the admission entry and discharge dates. When I subtract those 2, does that come out to 500 hours? Or does it come out to 300 hours or 200 hours, and this is an outlier, right? So these charts are really interesting. It shows, and you can see some patterns in it. For instance, if you look at these 2 guys, they're pretty close, right? They're both, and it's interesting, they're both obstructions. They have about the same median. One's a little less than the other. Their tails to the fourth quartile is about the same. And they've got about the same number of outliers, right? These 2 guys are kind of similar as well. So you can see you can look for some patterns across those diagnoses to see if there's something else you have to explore there. Okay. Now we started doing something different. So I took a look and I said, well, they have this column there called ethnicity. What exactly is that? And how accurate is it, right? So I looked at this, and this is a list of some examples. Actually, this is a list of a group of counting them by example, right? So you see a real mishmash here, right? You see white used in 2 different places. One is white and the other is white Russian. I'm not sure if somebody asked what drink the guy had last night, or and then you have all different varieties of Hispanics. You don't see all of it because it's not listing all 383 rows, but there was a real mix. So I said, you know what? Let me do some tweaking here. Now, when you're doing EDA work, when you're doing grouping like that, you have to be very sensitive, because when you produce a high-level group, that does 2 things. It might give you some sense of a pattern, but it's not giving you all the details. You're losing some details when you group things, right? So what happens is, if you make assumptions, and this is the whole definition of prejudice, right? If you group things together and you make an assumption about what that means, you're going to be wrong most of the time, right? Because it's people that are sick. It's not nationalities or ethnicities. But I wanted to group to see if there was a pattern that I could start with, and then I could drill down deeper and split them up into groups and split them up into ages and see if I see something else. Okay, I jumped in here and did something else in the meantime. So hold that thought. I'm going to get to it in a second. Again, I used the same pattern. I wanted to see if there was a difference between, because I noticed early on there was both emergency and elective. And I've got this set of diagnoses. Were there patterns in them, right? And this last one in the corner seems to be electives and emergencies seems to be about the same. It looks for IBS. It looks like there's a lot of stays that are less than 200 you work with. For the emergencies, some of them stay a little bit longer. Even for, it looks like for one of the non-emergencies, for elective surgery, there was a person that spent over $600 in the hospital. It sounds like maybe something happened that was unintended, or who knows what the deal was. They had a long time to figure out how to resolve it. This panel looks similar. Now, the thing to note is there's a lot more emergencies than there are not, right? Look at these numbers. They're small electives. This sounds like these conditions sounds like they're very much emergency based. They flare up, they need help, and then something happens, right? And then it resolves itself in some way. Okay. So that in itself didn't tell me a whole lot. Okay. The next thing I did is I said, let's look at these same diagnoses, split them up by emergency and electives, and do the box plots and see if it tells you anything different, right? Anything new, right? So this told me that for the gastric ulcer 25.0, the acute one, that the average length of stay, or the median length of stay, is actually greater for elective than emergency. Right? For the unspecified chronic ulcer, they're about the same. Though for the elective, it turns out that the range of length of stay is much broader. It sounds to me like what happens here is the person comes in for an emergency, they give them some treatment, and then perhaps they're scheduling surgery or something for them right here. Oh, get rid of the color there. This colitis, again, was an interesting one. The emergency one was a lot broader. The elective was very short. They come in, it looks like they stay less than 100 hours.
Now, the issue is the statistics aren't great, right? It's these outlier points. How many cases are there? Is it under 100 or is it 1,000?
No, it's in the thousands.
The dots themselves represent thousands of cases?
No. The dots represent one.
Okay.
But if you look at the 10,000 cases I'm looking at, it's more than 100.
Okay.
But you're right. That's right. You see so many of them, right? There's something going on in those dots. Why does most of the people deal in this one situation, but this poor guy was in the hospital for 2,000 hours, right? If it's because he was initially diagnosed with something else and the treatment didn't work, right? That would be a reasonable assumption, right? The guy goes in, everybody else has gone home. He's still in the hospital. They're still trying to figure out how to treat his condition. Was it because at the beginning he was diagnosed differently, right? Maybe going back to those descriptions that I showed you earlier that the doc scribbled into the admission that was different than the diagnoses. That might be an opportunity for improvement or an opportunity to kind of use artificial intelligence to tie some information perhaps that were missed in the patient's notes. Okay, so here I'm going back to that ethnicity thing. So what I did is I went through and I built a map here that basically sends my admissions back through a loop and basically says for every row, I want you to add a new column called ethnic group that simplifies some of those groups, right? And when we do that, here's the grouping, right? So you see I've got Asian, I've got a list of all the different groupings that we converted to a higher level group. We've got Black, we've got Hispanic, we've got Indigenous, Middle Eastern. I'm not sure, I wasn't sure where to put that, so I left it alone, right? Is that Spanish? Is that white? Is that, I wasn't sure what that meant. There was one guy identified as, actually 19 people identified as multi-race ethnicity, and there was 196 that said other, so I just lumped them together. There was a bunch, this is an interesting one. There's a bunch of people that just refused to answer the question, which is certainly their right. So a bunch declined, a bunch it was identified as unable to attain, and another was unknown. So I grouped those together as an unknown. And then I grouped a bunch of folks as white. And when I counted them, this is what I counted. So this is my new ethnic group and how it breaks down across all the admissions. And then I said, okay, well, let's look at, again, at a high level, just for an indication. I don't want to jump to any conclusions. Are there differences across the groups, the ethnic groups? Okay, and what I saw, first of all, there are so many admissions for whites in this hospital that the blue just overpowers everything, right? The blue is the greatest number every place. What I put on the labels, the text labels in the middle there, those are of all the people that had that condition, was diagnosed with that condition, how many fell into this particular diagnosis. So of all the people that identified as white that had one of these conditions, these 10,000 admissions, less than 1% was white or black. Over 1%, a little over 1% was Hispanic, and the unknowns were less than 1% as well. Now, most of this was close. Like, this is really close. You could certainly do a statistical test to see if there's a difference here. A t-test on the mean, but I didn't see that as a huge difference. But you look down on some of these, and some of these jump out at you, like this one over here, gastroduodenitis. A little over twice as many Hispanics have it than whites. Twice as many Hispanics also have gastritis. If you look at the ulcerative colitis, it looks like that's a white-specific disease because more than twice as many, 2.8 times as many whites have it than other ethnic groups. This one was close. This is interesting. This one, now there's not a whole lot of them, so it's hard to say, right? There's only, I don't have the counts here, but the highest at any one time of length of stay was 3. So you're probably talking about, if everyone was 3, I think these are quarters and there's 800 of them. So what's 800 quarters? That's 32. So if everyone was 3, and it's not, times 32 buckets, that's only 90 people, right? No, 90 days. So it's not a large sample, but it's interesting that there were no Hispanics at all that had this diagnosis. This is even across the board. And again, this one, it looks like Hispanics have a little bit less than everybody else. So that was some things to explore. And then it kind of goes on and on. Let's see. The accounts, I showed you that before. What am I doing here? Okay, so now we're getting to the interesting stuff, some more interesting stuff. So far, all we've been looking at is admissions, right? But my interest isn't only admissions. I want to find out, what about those patients' notes, right? What are the notes, the notes that the doctors and the nurses write, the people that deal most with that patient? How do they break down with all this stuff, right? And so what I did is I did another merge where, for all those admissions that I identified and we've been dealing with so far, let me tie their notes into that. And what do I got for notes, right? So here's some examples. What did I list here? This is just some data with the notes to show I did it right. So now I'm starting to do some counts. Now notes are like admissions, right? The person comes in the door, someone walks up to them with one of those wheeling carts with a laptop on top. It starts asking them questions and they're typing away. That's note number one. They get on a bed in a room, and the nurse comes by and the doctor comes by. That's notes number 2 and 3. They send them to MRI. That's notes number 4, right? As time goes on, we're collecting notes on these people. And I'm trying to think, what did I do here? Did I group these yet? I haven't grouped them, no. All I've done is I'm just aggregating them. Okay. So here's some high level numbers, right? So here are my diagnoses on the left again. These are the minimum and maximum size of notes and how many notes, how many, is it notes or admissions? How many admissions right into that, right? So I've got K25 0, I've got 42 admissions, right? And the average note, the median note was 110,000 bytes. Is that right? No, 11,000 bytes. And the high admission, the maximum was 134,000 bytes. And it goes up. But if you look down the list, you'll notice that this diagnosis has the highest maximum. It's got 606,000 bytes. Now, remember what I told you. These are not admissions. I'm sorry. These are not all the notes for one person while they're in the hospital. This is the largest size for one note. Lots of data is being collected, right? At some point in time, I said, what I'm going to do is I'm going to do the same thing with notes that I did with diagnoses. I'm going to write a routine that takes in all the notes for a person, for an admission, groups them together into one field, does some cleanup on them, and then stores them as one field. And this is what I end up with. Let me think, is this it? Did I do the grouping here? No, this is the same thing. This is let me go up here a little bit. I got to read my own code. Yeah, I don't think I've grouped the notes yet. This is just basic. Now, actually, this is me playing around with Matplotlib. So what I wanted to do is I wanted to compare stay of hours. I think this is stay of hours, and that's what it is. Stay of hours and average number of notes, right? So this is actually not average. This is the median number of notes for these two diagnoses, right? And what I'm trying to do is I'm trying to figure out, well, is there a relationship between length of stay in the hospital, in the ICU, and the size of notes? You would think there would be, right? I mean, you're in there longer, there's more notes being taken, there's more data about you, right? So here, I've got the note size by diagnoses, right? So I've got 25.0, I've got 42, those 42 patients. I've got a maximum 134,000, a median of 11,000. If I look at these first two rows, the second diagnosis has even though it has a higher max, it's got half the median size. And I'm looking, well, let's look at these two guys. Is there a difference between length of stay between these two diagnoses? What's interesting, the median length of stay is smaller for this diagnosis. Right? You follow that? The median for this diagnosis was 124. The median for this was 203. That's not quite twice, but you see the same relationship in the length of the notes, right? And I basically did that for each of these. So I basically mapped down and tried to see a relationship. And sometimes there were. Sometimes you saw that obvious relationship, like in that first panel, but a lot of times there aren't. And let me see if I can come up with a very good example. 56, 69. No, these two are about the same. This one's a little bit bigger. That's about the same. So this
I
is the
want
only one that, go
for
ahead.
you too. You're dealing with pretty small statistics, and you're trying to tease out relatively small changes. Are you familiar with a concept of bootstrap sampling?
No,
So the idea is you have actually point data, basically, each instance. And the fundamental hypothesis is that the first attempt at the distribution you're sampling from are those points. So you can mock up a resample of the distribution by doing a sample with replace. Actually, Pandas does a thing called bootstrap resampling or sampling with replace. I do it all the time.
You're talking about bootstrap. I heard rootstop. Yeah.
Sorry,
Yes, I'm
bootstrap.
familiar with
Yes.
bootstrap sampling, like for when you're building models.
Or you could do the
So
same thing.
so it's constantly sampling that base population, trying to
Yes.
see if you end up with a slightly different variation or what's the pattern in the sampling that results in a consistent picture.
Exactly. Yes.
Yeah.
The thing is, I think you're in the limit of the bootstrap sample estimates will probably be, you'll have an effective sigma larger than noise larger than signal for a lot of the small populations you have here.
You could be right. Yeah, you could be right. So to kind of summarize, what I'm going through this data and I'm trying to get a sense for how does admission, what's the population and what's the personality of the admission population? Are there things and characteristics in that should be part of my analysis? And how does that tie back to notes? And once I have that list, I know I'm going to be using the notes and using NLP processing to come up with a way of clustering these diagnoses. Are there other characteristics that I've explored through this that might be added to the mix to make a clear picture? So that's what I do when I do EDA. Are there questions or anything folks would like to add?
I guess for the paper that you're going to write off this, you might need to do some kind of bootstrap sample for the peer reviews to start listening to you or listening to the arguments you're making. And
right, yeah, this is
that is, you could also say what's the minimum sample size for which you expect, to be sufficiently large to, basically tease out these effects.
Yeah, makes sense.
Thanks for presenting. I think the problem that you chose to solve, I think, is definitely interesting.
I'm hoping.
Yeah, I don't have any questions, but that was just we want to say a really cool breakdown of data. I'm actually trying to learn Pandas, Matplotlib, and I can't think of the other one off the top of my head, but learning those right now in machine learning. So it's pretty cool to see it all kind of come together.
I hope it made some sense.
Yeah, I think so. Yeah. Thanks. Yeah, thanks for sharing it. I thought it was a really great. It's really wonderful when you can tell a story through data and like kind of wonder what's going on and like kind of slowly drill in and things like that. It's really cool.
You're welcome. Thank you.
Yeah, absolutely. Well, I'll tell you what. I'll stop the stream now, so it's just us.